Hi everyone, my name is Miss Watson and I'm going to be modeling the Explore activity that has to do with classifying matter. Now before I get started on my Explore activity, there's a couple things I need to do. First of all, since I'm not in my lab and I don't have my lab coat, I'm going to use an apron from my kitchen to protect my clothes. All right. The next thing I'm going to do is I'm going to tie back all of this long hair because I don't want it to get in any of the items that I'm using for my Explore activity. I'm sure that you have read or heard these safety procedures earlier in the week, or maybe it was last week. All right. So now I can start gathering items for my Explore activity. The first thing I'm going to need is my Explore Student Journal. Your teacher will provide this for you, and this is where you're going to fill in all your data. Now, one of the things the Explorer is asking me to do is measure for mass. So in order to measure for mass, my tool that I'm going to be using is a triple beam balance. So I have that. Then it asks me to measure if the items are attracted to a magnet or not. So I have my magnet. The third thing is it asks me the state of matter. Is it a liquid, a solid, or a gas? The next thing I'm going to be testing the objects for is relative density. Do they sink or do they float in water? If they float, they are less dense than the water. If they sink, they are more dense than the water. So here's my very small aquarium where I'm going to test the objects for relative density. Lastly, we're going to test to see if these objects are conductors or insulators. So I've made myself a circuit. And if I complete the circuit, if the circuit is closed, then my Christmas light will light up. So I know the flow of energy is going completely through the circuit. So the first thing that they asked for was to measure the mass of the items. Now the items that we are going to be testing today are a marshmallow, a penny, a ping pong ball, a golf ball, a paper clip, an iron nail, and foil. So I have all my things together ready to test. So first we're checking for mass. I'm going to use my triple beam balance to get the mass of each one of these objects. Your teacher is going to share with you the mass of each one of the objects. The next thing I'm doing is testing for magnetism. Which one of these objects is going to be attracted to a magnet? Let's start with the marshmallow. Nope, not attracted to the magnet. The penny. Nope, not sticking to the magnet. The ping pong ball. Nope, not sticking to the magnet. The golf ball. Nope. The metal paper clip. Yep, it sticks to the magnet. Therefore, it is attracted to a magnet. It has magnetism. The next one is the iron nail. What do you guys think is going to happen? It's attracted to the magnet. Iron is magnetic. And the last one is foil. Now it looks like metal, so maybe it's attracted to the magnet. Let's test it. Nope, not attracted to the magnet. The next thing that they're asking me to test is the relative or is the state of matter of each one of these objects. I think because of what you've learned in 2nd grade, 3rd grade, 4th grade, maybe even all the way back to kindergarten, you guys can tell that all of these are in a solid state of matter. They are all solids. All right, here comes one of the fun parts. We're going to skip over relative density and we're going to do conductor or insulator first. Because if I put all my objects in the water, they would all be wet. And water is a conductor, so I wouldn't get a very good response. I wouldn't get accurate data unless the items were completely dried off. So we're going to test for the flow of energy through each one of these items. Are they a conductor or are they an insulator? So I'm going to take my circuit that I have created and I'm going to place each one of the items in the circuit and we'll see if the light bulb lights up. First, let's test the marshmallow. Nope, the light bulb did not light up. Therefore, the marshmallow is an insulator. The penny, I think a penny's made out of copper. And these wires kind of look like there's copper. So let's test it out. As you can see, the light bulb lights up. Therefore, my copper penny is a conductor. The ping pong ball, let's see. I don't think that plastic is going to be a conductor, but still have to test it out. Nope, not a conductor. A ping pong ball is an insulator. And now a golf ball. My golf ball is an insulator. Next, we have a metal clip, your paper clip. Let's see if this is a conductor or an insulator. As you can see, the metal clip, when placed inside the circuit, is a conductor. It allows energy to flow through it. Got stuck. My next item is an iron nail. Let's see if this is a conductor or an insulator. My iron nail is a conductor. I know it's a little hard to see, but it is in there. My iron nail is a conductor. And the last thing is my foil. Let's see if this is a conductor. I'm going to place it in the circuit next to the battery. Let's see if it's a conductor. It absolutely is a conductor. Foil is a conductor. All right, now we are going to test for relative density. We're going to see which objects are more or less dense than the water. So I have my very small fish tank full of water, and we're going to put each one of the items in there. The marshmallow, it floats, so it is less dense than the water. My penny, it sank, so it is more dense than the water. My ping pong ball, let's see, it floats, so it is less dense than the water. My golf ball, what do you think? Sink or float? It sank. So it is more dense than the water. My paperclip, it's pretty lightweight. Might float. Nope, it sinks. It is more dense than the water. My iron nail sinks. It is more dense than the water. Now my foil. Let's see if it sinks or it floats. My foil floats. Therefore, it is less dense than the water. So, after I find out all of my information, I gather all my data, I can fill in my student journal and have all my data in one place. Your teacher will have this displayed for you so that you can record the data as well. Thank you for doing the Explore with me. See you guys next time.